this is very important example on uniform convergence. We need to prove that the series is uniformly convergent on the open interval 0, 1. So we are going to apply the Abel's test over here. What Abel's test requires is that if we consider this to be our unx and this to be vnx, then first we have to show that the infinite sum on unx is uniformly convergent. Secondly, we need to show that the sequence Vn is monotonically decreasing sequence. Right? And yes, it is monotonically decreasing sequence because of this given interval. So for 0 to 1 interval, x to the power n is monotonically decreasing sequence. Right? Okay. Third, we need to show that the sequence Vn is uniformly bounded. If we are able to prove all these three things, then by Abel's test, we say that this given series is uniformly convergent, right? So before starting with the proof, let's recall the Abel's test and the Leibniz test. So first one is Abel's test. The series summation on the product of unx and vnx converges uniformly for all x belonging to E if, first, the infinite sum on unx is uniformly convergent on E. Second, the sequence vnx is monotonically decreasing sequence of positive terms for all x belonging to E. And third, the sequence vnx is uniformly bounded on E. If these three results are to be proved, then this series is uniformly convergent by Abel's test, right? Then is the Leibniz test. This is also very important test. If Vn is a monotonically decreasing sequence such that Vn tends to 0 as n tends to infinity, then the alternating series, that is the infinite sum on minus 1 to the power n minus 1 and its product with this Vn, is convergent, right? Moreover, if Vn is independent of x, then this alternating series is uniformly convergent, right? So we are going to use both these tests. This is the given series and we have to show that this is uniformly convergent. And for this we are going to use the Abel's test, right? For Abel's test, we need to consider this to be unx and this to be vnx. So let unx is equal to minus 1 to the power n minus 1 divided by n and vnx is equal to x to the power n. So what is the first condition for the Abel's test? That infinite sum on this unx should be uniformly convergent, right? So we have to consider first the infinite sum on un, that is equal to the infinite sum on what is unx? It is minus 1 to the power n minus 1 divided by n. Can I write this as the infinite sum on minus 1 to the power n minus 1 and its product with 1 divided by n? So that I can have the product of these two. Because here we are going to use a Leibniz test. What the Leibniz test requires is that if Vn is a monotonically decreasing sequence such that Vn is tending to 0 as n tends to infinity, then the alternating series, the series of the kind infinite sum on minus 1 to the power n minus 1 into this Vn is convergent, right? So here also I am having the summation on minus 1 to the power n minus 1 and also 1 by n. So because we have already considered unx and vnx to be minus 1 to the power n minus 1 divided by n and x to the power n respectively, so let's consider this to be as capital unx and this to be as capital vnx, right? So for Leibniz test, vnx should be monotonically decreasing sequence, right? And it should tend to 0 as n tends to infinity. then the alternating series will be convergent. And yes, this 1 by n is a monotonically decreasing sequence and is also tending to 0 as n tends to infinity. Right? So let me write this. Since the sequence 1 divided by n is monotonically decreasing and tends to 0 as n tends to infinity, so therefore, by Leibniz test, the alternating series summation n going from 1 to infinity unx, that is summation n going from 1 to infinity minus 1 to the power n minus 1 divided by n is convergent. Okay. Now because this minus 1 to the power n minus 1 divided by n, this is independent of x. This is independent of x. So that means this series is not only convergent by Leibniz test, but also it is uniformly convergent. Please remember, for the uniformly convergent series, the positive integer n depends upon epsilon and is independent on the point x. But for the convergent series, the positive integer n depends upon both epsilon and the point x. This is the difference between uniformly convergent and the convergent series, right? And because this is independent of x, so we say that this series is uniformly convergent. So writing this, since unx, that is equal to minus 1 to the power n minus 1 divided by n. Please remember, here I have taken the small unx. That means I am talking about this complete minus 1 to the power n minus 1 divided by n. Please don't confuse this with, this is your capital unx and this is your capital vnx. And here I have written the small unx. That is convergent by Leibniz test. And now because this unx is independent of x, we are saying that this series is uniformly convergent. So writing further, since unx equal to minus 1 to the power n minus 1 divided by n is independent of x, therefore the infinite sum on unx is uniformly convergent. On the given interval, that is the open interval 0, 1. Right? So this is the first requirement for the Abel's test. Now the second one is to prove that Vnx is, what is Vnx? We have taken Vnx to be x to the power n. So second requirement is it should be monotonically decreasing sequence. And yes, clearly the sequence Vnx, that is equal to x to the power n, is a decreasing sequence, of positive terms on interval 0, 1. Third, we have to show that the sequence Vnx is bounded. For that, we have to consider the mod of Vnx, right? Now, since mod of Vnx, that is equal to mod of x to the power n. Now, this is strictly less than 1 because x is belonging to the interval 0, 1. And for all n belonging to the natural number. So for this mod of x, the power n is strictly less than 1. If still it is not clear to you, I am explaining this on the number line. So this is your interval from 0 to 1. You can pick any x from here. Let's say that x is equal to 1 divided by 2. And take any natural number. Let's say n is equal to 2. So what is x to the power n? It is 1 divided by 2 to the power 2, that is equal to 1 divided by 4, which is strictly less than 1. That is what I have said over here. So this mod is strictly less than 1 for all x belonging to the open interval 0, 1 and n belonging to the natural number. And because the mod of Vnx is strictly less than 1, so therefore the sequence Vnx is uniformly bounded on open interval 0, 1, right? So all these three requirements of Abel's test has proved. So now we can say that by Abel's test, the given series is uniformly convergent. So writing this, thus by Abel's test, the given series summation n going from 1 to infinity unx into Vnx, that is equal to summation n going from 1 to infinity minus 1 the power n minus 1 divided by n into x the power n is uniformly convergent on open interval 0, 1. Alright, thank you. Stay blessed.